Hello and welcome to Empowered Learning. In this video, we will graph the function x squared minus 4 divided by x minus 2. And this is the fifth example in the graphing rational function series. So the first thing that we need to do is to try to factor out the numerator. And we see that x squared minus 4 factors out to x plus 2 times x minus 2. And of course, we see right away that we have a common factor with x minus 2 in numerator and denominator. So what that tells us is that we can reduce those to 1 and just have x plus 2, where we have a whole at x equals 2. And we know that because that's where we have common factor in numerator and denominator. Okay. So looking at this, if you notice, what we've essentially done is said that our function f of x is going to look like a graph of x plus 2, but we're going to have a whole located when x is 2. So in answering some of the other questions that we have, like, do we have any x-intercepts? Well, of course, whatever makes the reduced form of the function 0 here. And so, of course, if we plug in a -2, that would make all of that 0. So we have an x-intercept at the point -2, 0. Of course, for y-intercept, by definition, if we let x equal 0 and figure out what y is, we'll see that if we let x equal 0 here, then corresponding y value is 2. So from that, we see that our y-intercept is at the point 0, 2. Now, as far as vertical asymptotes, we see that we do not have any factors in our denominator here. So because of that, we have none. For, let's say, horizontal or oblique asymptote, since degree of numerator, which is 2, is larger than degree of the denominator, which is understood as 1, we have an oblique asymptote in this case. And the oblique asymptote is actually the reduced form of the function, because if we divide x squared minus 4 divided by x minus 2, what we get as our quotient is x plus 2. So what's actually left in the reduced form of the function for this time is actually what the oblique asymptote is. And let's see if we can get that 2 to act to write correctly there. See, I'm not having much luck with that. We'll try one more time. All right. And so now, for our last two questions is, will the function cross the, in this case, oblique asymptote? Well, what the remaining function looks like is the oblique asymptote. So of course, it's pretty much going to look like this everywhere we go. So there's no need to do that. And then the last thing is the behavior around the vertical asymptotes. Since we have no vertical asymptotes, there is no need to study that. So now let's just go ahead and graph. So of course, where's our hole going to be located at? We can plug in 2 into our reduced form of our function here, and we'll quickly see that that's going to be, if I can get the 2's to come out looking right, that's just going to be at the y coordinate of 4, so you will have a hole at the point 2, 4. So knowing that, we can finish up everything else. So I'll go ahead and rewrite this. And then after that, let's go to our graph. All right, so here we know that this graph is going to look just like the graph of x plus 2, with the only difference being that at the point 2, 4, we have a hole. So I'll go ahead and label axes again. And of course, at the point 2, 4, and this time I'll draw it, let's see, 1, 2, and then go up, 1, 2, 2. So that'll be 2, well, 1, 2, 3, 4, yeah. So right here you'll have a hole. And then of course, we know we have an x-intercept at x equals -2, which is here. We know we have a y-intercept at 0, 2, which is here. And we would just draw. So this looks like a line. So we'll come here. This essentially is a straight line. And that continues on like that. And even though it looks like a line with a hole in it, technically speaking, it is considered a rational function. And so this concludes the example of x squared minus 4 divided by x minus 2, graphing this rational function. Please check out the last example, which is example 6.